After 1945, Germany was supposed to never have an army again. However, within 15 years they had a new one, and by some strange twist of history, it would be armed with the very same machine gun they had been firing at the people who were now their allies. So I'm going to show you how all of that happened, and the story behind what many call the best machine gun ever made, the MG3. We need to start with its infamous ancestors you've heard so much about in documentaries, chewing over the same few facts. So we're not going to do that here, but instead show you the other side of German engineering. It all started back in the 1930s, when Germans came up with the MG34, the first true general-purpose machine gun, at a time when every major military still split its machine guns into 2 or 3 different classes. Maxim-style, water-cooled heavy machine guns, light machine guns fed by magazines like the British Bren, then special machine guns for aircraft or vehicles, and so on and so forth. But the Germans had the idea that one weapon, with different mounts and accessories, could do every machine gun job there was. Light machine gun on a bipod for the squad during an attack, heavy machine gun on a tripod for sustained fire from a defensive position, or anti-aircraft gun on a tall mount. Even coaxial or bow gun in tanks, and pintle-pointed gun on vehicles. One gun, one cartridge, one logistics chain, one set of trained gunners. That was a major conceptual leap, so far ahead of its time, and it set the template for what every modern army calls a GPMG today. It was chambered in the standard German 7.92x57 Mauser rifle round, and we can freely say that it was the most advanced machine gun in the world when it appeared, whether we like to admit it or not. The MG34 became the main German machine gun for the invasions of Europe through 1939, 1940, and the early phase of the Eastern Front in 1941. It was light enough to be carried by one man, it fired at a cyclic rate of 900 rounds per minute, had a revolutionary quick barrel change system. I mean, the squad-level fire support that the gun provided was unlike anything Allied infantry would have until even well after the war. Beautifully made, finished to high-quality civilian rifle standards, every part precision-milled from solid steel. So you might now be wondering, if the MG34 was so good, why did the Germans go looking for a replacement so early? Well, each one took about 150 man-hours to complete. Each consumed about 50 kilograms of raw-quality steel that Germany didn't have reliable supplies of. Almost every part was milled from solid steel stock, on machine tools, by skilled labor. There was nothing simple about it. Not to mention speed of production. Germany literally couldn't produce them fast enough to meet the demand they had. Then, that same precision engineering and tight tolerances that made the gun so accurate and so finely finished also made it horribly fragile in real battlefield conditions. The MG34 was sensitive to dust, mud, sand, extreme cold, none of which you'd lack in war, obviously. So they wanted something cheaper, faster to produce, simpler, tougher in field conditions, but also one that kept the universal concept and worked with all the accessories built for the MG34 just the same. Quite the engineering challenge when you hear those ambitious requirements, but it's how it is. Now, what's interesting is that the competition for a new machine gun, which would be solely responsible for what the MG3 looks like today, wasn't won by those famous weapons designers and companies, but by a company that had been making household goods. They were making things out of sheet metal for anything you might need in your house or backyard, but they had never worked with weapons. However, they received a design contract for a new machine gun because they knew how to produce things fast and cheap. So their leading engineer, Dr. Werner Gruner, and remember this guy because he's important for later, actually asked the German Wehrmacht to go and participate in a machine gun training course, so he could see how the machine gun was supposed to work, what it was supposed to do, and what problems soldiers had with it in practice. And of course, after some time through ups and downs, they actually had the prototype. It was completely different than anything else at that time. Instead of a gas operating system, it had a simpler recoil-operated roller lock system. Everything except the barrel, bolt, and a few other parts that handle high pressure from the fired cartridge was made from stamped steel and spot-welded, which was just shocking at a time when real military weapons had to be milled from solid forged stock. Then the trials came, and other designs by serious weapons factories outperformed this thing in testing by a wide margin, which was, not really a surprise. But the new crappy-looking stamp design was picked anyway, because this wasn't a trial for the best performing machine gun, but for the one most suited for mass production. And using stamping technology meant that it could be produced cheaply and very quickly, which was exactly what the Germans needed. Alright, before we continue, I want to tell you about the tool that helps me research these videos properly, because I think you'll find it useful too. It's called Chat LLM by Abacus AI. The whole concept is that instead of juggling 5 different AI subscriptions, you just have one. And it's not a watered-down version of any of them either. You're getting the actual models themselves. ChatGPT 5.5, Gemini 3.1 Pro, Claude Opus 4.6, Grok 4.1, DeepSeek, all in one place. And they've got this thing called Route LLM that automatically routes your prompt to whichever model handles it best. So you're not sitting there guessing which one to open. Beyond the chat models, you've got image generation through Nano Banana Pro and Flux, video generation with Sora 2 and Kling 3.0, and it'll even put together deep research professional presentations for you. And then there's the Abacus AI agent, which is genuinely impressive. It can build full apps, websites, mobile apps, and even other AI agents from scratch. All of that for $10 a month, which is way cheaper than paying for each of those tools separately. So go check it out at chatllm.abacus.ai. Link is in the description and pinned comment. Alright, back to the video. Because of a few things about this design, the new gun could fire much faster than the MG34. While the MG34 cycled at 800 to 900 rounds per minute, the new design cycled at roughly 1200 rounds per minute, with some versions that had lighter bolts going over 1500 rounds per minute, which was just insane. Then we have the looser manufacturing tolerances of the stamped steel design, which a precision engineer would normally consider sloppy, but they actually made the gun way more reliable in battlefield conditions. The MG34's tightly fitted parts jammed when grit or mud got into the action. The new gun, however, with its more generous internal clearances, just kept running with all that dirt inside regardless. The new design took 75 man-hours to assemble, cutting the time with the MG34 literally in half. It consumed about 28 kilograms of raw materials against the MG34's 50. At wartime production scales, those differences could be the difference between winning and losing the war. I said could. Not that they did, but still. The gun went through further refinements, and it was issued to selected units for combat trials at the end of 1941, and the results led to the machine gun being officially adopted in early 1942. So it got the final name MG42 and was now pushed into production at full steam. However, it never fully replaced the MG34 for a few reasons. The first one was production. They already had the factories making MG34s, and retooling them to produce new weapons would just cause a pause in production. And they needed the parts for the existing MG34s already in service anyway. The other reason was that the MG34 was the only machine gun Germans used inside their tanks, like a coaxial or hull machine gun. That's because the quick barrel change system was actually very different than the MG42's. It was slightly slower and more awkward for field use because you need to twist the receiver around and then pull out the barrel from behind the barrel jacket and then put in a new one. While the MG42, you'd have this latch on the side that disconnects just the barrel and pull it out like that. It was easier and faster outside, but inside a tank, you didn't have that space without redesigning the turrets and hulls. The MG34 didn't have this problem, so they were kept as tank machine guns for the entire war. But Germans made over 400,000 MG42s, so it was really close in production numbers to the MG34 despite starting a few years later. But why am I talking so much about the MG42 in a video that was supposed to be about the MG3? Well, if you know why, you understand, but if you don't, it's going to be very clear to you in a bit. The MG42 fired from an open bolt, so the design was actually pretty simple. It didn't have a semi-auto option like in the MG34. The trigger controls only a sear that holds the bolt to the rear when the gun is cocked. When you pull the trigger, that sear drops and the bolt is released and it fires the gun for as long as you keep the trigger pressed. so there's not much that could go wrong with it. The cocking handle and the catch for the top cover were designed with lessons from the Eastern Front, so that a gunner could work with thick gloves. Of course, what everyone talks about is the rate of fire, that well-known number between 12 and 1,500 rounds per minute, which terrified the Allied soldiers so much that it inspired all those ridiculous nicknames and whatnot. Now, keep in mind that this was at a time when the Allied machine guns were all firing between 500 and 650 rounds per minute. So it's not strange that the Allied soldiers hated German machine guns. The Germans wanted a higher fire rate than anyone else because they had seen how important it is to put as many rounds as possible on a target in the shortest amount of time, rather than having a sustained fire for a longer time at lower rounds per minute, if that makes sense. The Germans would have the same number of rounds on their targets as the Allies, just in a much shorter time. The second thing was shooting at low-flying aircrafts, where you also need as high a cyclic rate as possible. And that insanely high rate of fire was achieved with a roller-locked recoil action. And with the help of this muzzle booster, which looks like a flash suppressor, but it's alright. But the Germans didn't want this machine gun to be used to spray bullets all over the place. The doctrine was to fire short, controlled bursts and to change barrels very often. Gunners were trained to fire bursts of 3 to 7 rounds, but you'd need quite a bit of training to achieve that, and not rip a 15-round burst with the weapon that fires 20 rounds per second. The German instructions for the MG42 explicitly forbade firing bursts of more than 250 rounds in a single trigger pull, while the recommended interval for barrel swaps was in theory around 200 rounds, although in practice, in the heat of battle, gunners pushed this way higher. The barrel housed in the stamped barrel sleeve, which is open down the right side, is easily pulled out by opening a latch, and the barrel then slides out the rear right of the gun. A new barrel was then put in, the latch slammed shut, and the gun could continue firing. Experienced gunners could swap the barrel in about 5 to 7 seconds, although real-world conditions were always something different. Its belt feed mechanism is actually one of the most copied designs. The MG42 is fed from non-disintegrating metallic link belts, which are produced in 50-round pieces that are then connected in longer belts. The standard German ammo box takes 250 rounds, and just take a look at the ammo cans for a moment to see how far ahead the Germans were thinking. The Allies had nothing remotely close to such things. They were waterproof, with the neat little carrying handles positioned close to one side so you could carry 2 cans in one hand. Try doing that with the Allied ammo cans. The handles could also be folded so you could stack ammo cans inside your tank or bunker, and they could be clamped onto belts or Lafette tripods. And while we're at Lafette, this is, in my opinion, the most ingenious thing about World War II machine guns. It's unlike any tripod in the world, and this thing turns a light machine gun into a heavy machine gun. The Lafette tripod weighs some 40 pounds and can work with both the MG34 and 42. And it unlocks the machine gun's full potential to make horror stories on the opposite side of it. It has recoil-absorbing buffer springs that make the gun much more controllable and deadly accurate, even at long range. It has traverse and elevation mechanisms, which the gunner could use to preset the zone where he'd fire. He could put a telescopic sight on it, or even a periscopic sight, so he could fire from the safety of the trench or use the periscope for indirect fire. However, the most interesting feature, above all, is the Tiefenfeuer Automat, roughly translated to something like searching fire device. The idea is that if the gunner is unsure of how far the target is, or wants to cover some specific area with fire, he could use this analog computer to preset that zone. Then when the gun starts firing, this thing would use the recoil to move the gun, sweeping it across that entire zone. This way, the gun crew could saturate that area with fire, and even use the machine gun like a really light artillery piece. The gunner could also tie a string to the trigger and then fire from cover. And the Allies hated the Lafette tripod because one well-positioned machine gun with it would give them a hell of a time. The gun was much harder to locate because it was low to the ground and usually quite well protected, and the fire coming from it was just deadly accurate. They could quickly change barrels while the machine gun was in the tripod, and the Germans had multiple prepared alternative firing positions whenever possible. So they'd fire from one position, and as soon as the soldiers on the other side figured out where the fire was coming from and started trying to neutralize it, the Germans would quickly pack their machine gun and go to the next position and just fire from a different angle. This way, they also created an illusion that they had many more machine guns than they actually did. So now you're wondering, how come when the Germans had such an advanced weapon at that time, no one took a captured example and just reverse engineered the thing? Well, actually, they did. The Americans in particular launched a T-24 program where they tried to make the MG42 in 30-06 to arm their troops with it. But they couldn't make it work with the different ammo, and the whole project was eventually scrapped. Okay, so having the best machine gun in the world did not help the Germans to win the war, and they lost it for various other reasons. I mean, they were pretty much fighting against more than half of the world, after all. The war ended, and the Germans' factories, weapons, engineers, and scientists were all now in the hands of the Allies, grabbed by the Western and Eastern blocs, whichever could get more. The bunch of MG42s that were now lying around got scattered all over the world. Some of them, like Yugoslavia, captured large numbers of MG42s, and they began making their own exact copy of it and put it in service. This was the M53, pretty much an exact duplicate of the German version, and in the same caliber. It only had a slightly lower cyclic rate of about 950 rounds per minute, and it was used for decades in the Yugoslav army and was also exported to Iraq in large numbers, where it was eventually fired on the Allied troops in Desert Storm. But how was the MG3 born? Well, after 1945, Germany was disarmed, occupied by the Allies, and divided into zones of occupation to make sure that the Germans would never have an army again. But this began changing in the years after the war, and I won't bother you with the Eastern and Western blocs and the tensions there. In short, the Western Allies were worried about a war with the Soviet Union, and the border was now in Germany. They figured it would be nice if Western Germany now had an army to help them out in case another global war broke out, so they created the Bundeswehr. It was the name given to the Western German army to make it different from the World War II Wehrmacht, and it meant something like federal defense. Anyway, the Bundeswehr was under NATO command from its first day, and they now needed to reconstruct and modernize their armament. They looked around at what NATO had and basically concluded that they could do much better. And not only that they could, but that they already did have something much better, some 10 years ago. The good old MG42. But they had two problems at first. The first was the cartridge. NATO had standardized the 7.62 by 51mm, so all alliance nations had to use it to make it easier to support each other in case of another war. So they had to change the caliber. And the second problem was that all of their blueprints, specifications, and drawings for the MG42 production were pretty much just grabbed by the Soviets. The Germans now had to reverse engineer their own gun. And the guy I told you about at the beginning of the video, the one who was the main engineer of the MG42 program, well, he was still alive and still working as an engineer. But he was on the other side of the Iron Curtain. He was grabbed by the Soviets in an operation where they gathered all German technical specialists they could find and brought them to the Soviet Union, where they were pretty much forced to give all the Soviets the knowledge that they had. But Rheinmetall finally pulled it off through that not-so-simple process, and reverse engineered the MG42 and made all the specs for production of the new machine gun. They chambered it in the new NATO standard round, which was pretty similar to the original 7.92 Mauser anyway. The new production machine guns in this caliber were designated MG1, while the original MG42s that were rechambered in 7.62 NATO got the name MG2. Now, the MG1 evolved through a series of variants in that new caliber, and over time, improvements were being made. They also reduced the rate of fire to somewhere more comfortable, between 700 and 900 rounds per minute, by putting in a heavier bolt. All of these small but important details were what eventually led to the MG3. All earlier variants were converted to the MG3 standard by adding all those improvements to them. However, the machine gun at its core is still on the same operating system as the old MG42. The barrel change procedure is the same, and pretty much anyone familiar with the MG42 can pick up the MG3 and work with it just the same. Even a bunch of parts are interchangeable with one another. A lot of Western Bloc countries adopted the MG3 for their armies, or licensed products in their own versions. It was heavily used in various wars after that, but by the early 2000s, it was beginning to show its age. The basic design was 60 years old, and the German Bundeswehr began looking for something new. They started with what they called combat upgrades of the MG3, like adding Picatinny rails, an adjustable buttstock, adjustable rate of fire, and so on. But then they did something opposite to the whole MG42 family and concept they were based on. They made the new MG3 receivers from solid steel to extend the life of this World War II design. But they concluded that they couldn't stretch this indefinitely, and they began developing a new general-purpose machine gun in 2006. This is what was eventually adopted as the MG5. Now a completely different design, gas-operated with a rotating bolt, and it pretty much has nothing in common with the MG42 lineage when it comes to the operating system.